Step 1 is to decide whether we're going to solve for x or solve for y. So let's look at our two equations. And we can see here that only y has a coefficient of 1, so it would be easiest for us to use the second equation and solve for y. So let's go ahead and proceed with that. To solve for y, we need to subtract 5x from each side. And now we're going to take that expression that we solved for y and plug it into the other equation in that variable's place. Just for the sake of name, we're going to call this equation we just created equation number 3 because we're going to use it later. All right, now for plugging in, again, I got this from equation 2. So I can't plug it back into equation 2. You always have to plug it into the other equation. So I'm going to plug it in equation 1 in y's place because I solved for y. Now we're going to solve the equation. We're going to use the distributive property. Negative 4 times negative 5x equals positive 20x. Negative 4 times negative 2 equals positive 8. Combine like terms. 3x plus 20x equals 23x. Subtract 8 from each side. Divide by 23. And x equals negative 1. Now we're going to take the value that we have of x and we're going to plug that into our equation 3 that we created earlier because it is already solved for the variable we want. All we need to do is plug in that negative 1 to the right and we'll know what our value of y is. So removing the x, replacing it with negative 1, negative 5 times negative 1 is positive 5, and 5 take away 2 we know is 3, so our solution is negative 1, 3. Now it's optional, but you can always check your solution if you're not sure. Just plug your ordered pair back into both original equations, and if it leaves you with a true statement for both, then that is your proof that the solution you have is the solution to that system of equation.